Hi, welcome to topic number 8. In this lecture video, we're going to talk about what is so-called the measure of dispersion. Okay, measure of dispersion. So the word dispersion means it's a measuring of the spread of a data set. Okay, so if you have bunch data, it's talk about how wide it is, how wide, how much it spreads out, okay, of a data set. So we will use the word range. We will use the concept of range, variance, and standard deviation to measure the spread of the data. Okay, so let's take a look at the range. Okay, the range of a raw data. The range of a data set is the difference between the maximum data value and the minimum data value. Okay, the maximum and the minimum data value. Okay, so if you take those two numbers and subtract them together, that's the word difference here means, then you find the range, okay, which is the spread of your data. So if I take a look at these 5 numbers, for example, the range got to be the maximum data value, which is 100, minus the smallest data value, which is 70. Then this data has a spread of 30 points. Okay, so these are, for example, these 5 are test grades. Okay, so the test grades has a 30 points, okay, spread difference. All right, let's try this one. Same thing, find the range of the following 5 test grades. So the range, say the largest data value, which is 55, which is 60, excuse me. Minus the smallest one, which is 25. All right, 60 minus 25. The data spread is 35 points. Okay, so the 2 example here has a very similar spread. But of course, we want test grades to be on the higher end rather than what? Rather than on the lower end. Okay, so the range is simply implies, okay, the spread of a data. So you can have 2 sets of data, have a very similar spread, but the data value in there can be significantly different. Okay, using these 2 examples, for instance. Okay, of course, you want test grades to be on the higher end rather than on the lower end, even though the range is very similar. The word deviation, okay, the word deviation, which is actually another way to talk about the spread of the data. All right, the word deviation means how far away are each data set or each data value is to the mean. Okay, it's talking about the distance to the mean of your data. So find the distance of each test scores. Okay, so again, let's go back to when we talk about, the central tendency, what lies in the middle. Okay, right now, this is about the spread of the entire data. So eventually, everything is boiled back down to what lies in the middle. What is the mean of your entire data? So this deviation is just a way for us to see, okay, how far away, how much distance away is each data value to the mean. So at the same time as I'm doing this example, I'm also trying to derive the formula down here, okay, which is your standard deviation and the word variance. Okay, so individual data are called xi. Individual data is called xi. So I got 70, 88, 90, 72, and 100. Okay, the distance to the mean. So I need to find the mean first, right? I need to find the simple mean first. So if I take 70 plus 88 plus 90 plus 72 plus 100, add them up first, then divided by 5. My average, my mean is 84. So the distance from individual data value xi minus the x bar, which is the mean. So this will be 70 minus 84, 88 minus 84, 90 minus 84, 72 minus 84, and 100 minus 84. So 70 minus 84 is negative. It's actually negative 14. The negative here means your data value lies below the mean. The negative sign here means your data value is actually to the left. It lies to the left of your mean on the number line. Okay, 88 minus 84 is positive 4. So that means 88 is 4 places to the right of your mean. 90 minus 84 is positive 6. This is going to be negative 12 and positive 16. Okay, so the positive value after you subtract means no data value lies to the right of your mean. Negative number here means those data value lies to the left side of the mean. Okay, now we're talking about distance, right? Distance is normally positive. Distance is normally measured in positive. So what I can do is take these answer I just get, the xi minus the x bar. What I can do is square them. Because if I square each one of these numbers, it will all become positive value. So if I take the entire negative 14 whole thing squared like this, I get positive 196. So 4 squared is 16, 6 squared is 36, negative 12 whole thing squared is positive 144, 16 squared is 256. Okay, so the reason why I'm squaring them is so that I can actually, so they can all be positive value, because normally when we talk about distance, it's always positive value. Now, if I add them all up, if I sum of all these numbers I just squared it, okay, I should get 648. If I add up all these numbers here, I should get 648. Okay, so remember, I have 5 data values. So if I would take, so instead of taking these negative 14, 4, 6, negative 12, 16, add them all up, divided by 5 to find out, to find the average distance. Okay, so we already found the distance of each test score. Right now, I kept going to find the average distance of each data set to the mean, each data value to the mean. So if I will take this number divided by 5, $648 divided by 5, I get about 129.6. 648 divided by 5, 129.6. Okay, so this number, okay, is actually called the variance. That is actually the variance. Okay, so now if I take a square root, which is of this 129.6, sum of all the xi minus x bar whole thing squared, whole thing over n, which is square root of 129.6, square root of 129.6, I get about 11.38. Positive, negative 11.38. Because in the algebra class, when you take a square root on both sides, your answer should always be positive, negative. Okay, so this positive negative 11.38 means on average, each data value is about 11.38 places away from the mean. Okay, let me say that again. This is positive negative 11.38 means on average, each data value is about 11.38 above or below the mean. That's how much distance on average those data value is to the mean. So the word variance and the word standard deviation both means on average, how far is each data value from the mean? Okay, that's what the standard deviation and a variance represents. The difference between a variance and standard deviation is that the standard deviation is a square root of a variance. Okay, so the variance was 129.6 earlier. So when I take a square root of it, that will be called a standard deviation. Okay, so standard deviation variance means on average, how far is each data value to the mean? Okay, so what we come up with is about 11.38 places away, above it or below the mean. Okay, so here are your formulas for population and simple variance and standard deviation. So as you can see from the formula, the difference between variance and standard deviation is by the square roots. Okay, so everything I just wrote here is basically showing you how to find variance and standard deviation by hand. Okay, so not very practical, when we actually have a lot of data values. So that's why I only use 5 of them. Okay, the simple variance formula is slightly different than the population because the denominator here, instead of divided by the simple n, is always divided by simple minus 1. Why? Nobody know why. It just turns out when you take the simple, subtract one simple, normally that answer is actually more accurate. Okay, nobody know why. It just discover that simple variance, simple standard deviation is always n minus 1. Okay, in the denominator. Then we're gonna see that n minus 1, the simple minus 1 in other formula as well later on the semester. Okay, so here I wrote a note, the larger the standard deviation, if that standard deviation is larger, it's bigger and bigger and bigger, what I'm saying, big number, that means the more spread of the distribution has. Okay, so here again is that word distribution. Distribution describes, like we talk about in other topic, distribution describes, okay, the spread of your data set, or the look of your data set. So the word distribution also means the table that we normally create, but it also means the graph. Okay, so let me go back to our previous topic. I think the topic number 6. If I go back to topic number 6 real quick, let me see if I can find it. At the end of topic number 6, we're talking about the distribution. So that's when we talk about histogram and things like that, because eventually we're gonna come up with this thing called the normal distribution. Okay, normal distribution is the bell curve shape, right? And we can have skew right or skew left in our distribution. So the word distribution is also means a table, also means the graph of that table. So the larger the standard deviation, the more spread the distribution has. So that means the wider this graph is. Okay, so that means the wider of these bar going to be. Okay, the width of these bars will actually get, it can get a little bit bigger. Okay, stay tuned. You will see why. You will see what I mean by that. Okay, in other topic. All right, here are your notations. Okay, so sigma, this little squiggle thing is called sigma. Sigma square or sigma. Okay, so this notation, this is called sigma. How about that? Sigma is a word I will use for population standard deviation. Okay, simple standard deviation is using a lowercase s. X bar is simple mean. Population mean is called mu. It's not a u. It's not quite a u. It's a Greek letter. I wrote like a u. Mu. Okay. population mean. Okay, capital N is population size. Lowercase n is sample size. Xi is individual data value. Okay, so just someone, so these are all the notation we have seen so far from these formulas. So rather than find our standard deviation by hand, okay, we can actually use calculator to help us. So when you do see individual data value, this is called the raw data. Okay, so here are the steps on how to find standard deviation and variance, okay, from the raw data. So the calculator will only display the standard deviation. So if you ever need to find variance, you will just square it. Okay. If you are given the standard deviation, okay, if you're given standard deviation like 11.38, all you gotta do is square that number to come up with variance. If you come up with variance first, then take a square root of it to get to standard deviation. So let's put this in the calculator. Okay, so if you follow the steps, go to stats, choose number 1, edit. Okay, so here are the numbers that I got last time, which is the same number as I get. So make sure we got 10 numbers. Last one is 39, 52. So make sure all these numbers are still the same. 45, 42, 48, 47, 47, 46. Okay, so the number, so these number came from our previous example from other topic. So once you enter all the numbers, press stats, highlight the word calc, choose number one variable statistics. Since all the numbers that I enter is on the L1, here I can just go ahead and press enter. Okay, if your calculator is look a little bit different than mine, just make sure your X list is L1. There you go. Your sample standard deviation. 3.90. Just run a couple decimal place. So what this number means is, on average, each one of these data value together, average wise, is about 3.9 places above or below the mean. And the mean is 44.9. All right, let's do same thing, but let's use the group data. Okay, so the following data is a group data, it's final exam score in a class. So when we're dealing with group data in the calculator, we gotta, under L1, we gotta type in the midpoints. Okay, so let's find the midpoint. Before you find the midpoint, find the class width first. Makes it easier. All right, take 2 consecutive lower class limits, subtract together. So 73 minus 66, my width is 7. Okay, so class midpoint, the first class, as you can recall, take the lower class limit plus the upper class limits, then divide it by 2. So 66 plus 72 first, then divided by 2. 69. Okay, so from here, all you gotta do is add 7 at a time, because the midpoint is basically the center of the histogram, each bar. So the width is always the same on the histogram, remember? So that's why I can just plus 7 each time. It will tell me the midpoint of the next class. Okay, keep on adding 7. $90, $97. Okay, so all this go under L1. So here are the steps. Okay, you can look at the steps as we key it in together. So stats, number 1, edit. Okay, I'm gonna go up, highlight L1, press clear, press enter, so you can clear out the list. Okay, so midpoint, go underneath L1. press the right arrow key. So it'll put you on the top of L2. So 6, 5, 3, 12, 14. All right, once you finish, press the word stat again, highlight the word calc, choose number 1. So this time we did put things under L1 and under frequency under L2. So here I will say second L1, comma, second L2. So X list is L1, frequency is under L2. Press enter. And I think this part want me to find the population standard deviation. So sigma, so 2 decimal place, it's about 10.13. So my sigma is about 10.13. So that means on average, individual data value, okay, is about 10.13 places away from the mean, and the mean is about 87.025. So just once again, remind you, why did we use midpoint? Because frequency 6 is in between 66 to 72. We don't know exactly what each one of those 6, raw value is. So we are assuming all 6 of them are 69. Okay, so we are making that assumption. So yes, this is an approximation answer. Okay, the 10.13 is approximation because we are assuming, since we don't know the raw, the raw data or the individual data value, we are assuming all 6 number here, frequency 6 is all 69. Okay, we are assuming there are five students score 76. Okay, so that's an assumption, okay, when we're dealing with grouped data. All right, let's take a look at your homework real quick. Question number 1, 2, and 3 come from the lecture handout we just talked about. So the difference between a variance and standard deviation is that a standard deviation is a square root of a variance. Okay, square root of a variance is up here. It's a square root of a variance. Question number 4. Use a calculator, please. Use a graphing calculator to spell that word. Did I spell it? Spell that word wrong. All right. Use a graphing calculator in the following steps to find the simple standard deviation. Okay, so do what I just showed you. Question number 5. Okay. The following frequency distribution represent the score on the test. So this question has 2 parts. Number 1, I want you to find the class midpoint of every class. Okay, so yeah, so in D2L, make sure you enter, okay, all the, make sure you enter the five midpoints. Okay, go from small to large, enter the 5 midpoints, and then number 2, use a graphing calculator and the following steps to find the population standard deviation, and make sure you round your answer to 2 decimal places. Okay, enter your answer in, enter your answer and round them in 2 decimal places for me. So make sure you answer both number 1 and number 2. Number 1, enter all 5 midpoints. Okay, number 2, just enter the population standard deviation, whatever the calculator showed you. So make sure you double check the frequency that you enter is correct. Okay, so a lot of time if you enter a number wrong, you will not even know your answer is a little bit off. All right, so that will conclude this lecture video on the measure of dispersion, okay, in terms of talking about range, variance, and standard deviation. Thank you for watching.